In solar module manufacturing, one key number defines competitiveness: the cost per watt. In this short video, we'll see how it's calculated and what really drives it. The cost per watt tells us how much it costs to manufacture 1 watt of solar power. To calculate it, we take the total cost of all materials in production and divide it by the total power of the modules produced. In simple words, we add up what it costs to make all modules and then divide that number by the total number of watts they deliver. For a single module, it's the same idea. You take the manufacturing cost of the module and divide it by its rated power. For example, if one module costs $31 to produce and has a power output of 550 watts, that means roughly 5.6 cents per watt. This is what we call the cost per watt. When we look at the total manufacturing cost of a solar module, we can divide it into two main parts. The first part is the material cost, everything you need to build the module, like cells, glass foil, and the frame. The second part is the production cost. This includes energy, maintenance, labor, and the depreciation of the machines. In most factories, materials make up roughly 3/4 of the total cost and production the remaining quarter. Understanding these two groups helps us see where most of the money goes and where improvements have the biggest effect. Most of the total module cost comes from materials, and within that, one part dominates: the solar cells. The cells alone usually account for around 60 to 65% of all material costs. The remaining 35 to 40% come from glass encapsulant, backsheet, frame, junction box, ribbons, and other small parts. So when material prices change, especially for cells, the total module cost changes immediately.
Let's take a simple example to understand how the cost per watt is calculated. Imagine a factory producing a standard 550-watt solar module. The total material cost is about $26. In production adds another $5. That makes $31 in total for one module. If we divide $31 by 550 watts, we get around 5.6 cents per watt. These numbers are completely fictional and only show how the calculation works. Actual costs change all the time depending on materials, efficiency, and local conditions.
The cost per watt can change a lot from one factory to another. The biggest factors are the level of automation, the size of the factory, energy consumption, and production yield. Higher automation usually reduces labor cost but increases investment. A larger factory can buy materials cheaper and distribute fixed costs better. Good energy efficiency and high yield also help to keep the cost per watt low. Around the world, production costs vary widely. For many years, China had a strong advantage because of low labor cost and massive production scale. But as module prices continue to fall globally, labor cost is becoming a larger part of total manufacturing cost. This means that countries with lower wages, for example in Africa, India, Vietnam, or parts of Eastern Europe, can now use this advantage against China. Local production in these regions can already compete, especially when logistics and import costs are considered. In the early years of solar energy, the module was the single largest cost driver of every project. Sometimes more than half of the total investment went into the modules alone. Back then, even a difference of 1 or 2 cents per watt could decide if a project was profitable or not. But things have changed dramatically. Over the last decade, the total project cost has dropped, while installation, logistics, and financing have become the dominant factors. Today, the solar module is only a small part of total project expenses, often less than 15%. That means saving 1 cent per watt on module cost has almost no real effect on the overall project budget. However, the module still determines how long the project will last and how reliable the output is. High-quality modules reduce the risk of failure and secure long-term returns for investors. So the focus has shifted from the cheapest module to the most reliable one. This makes it much easier today to position local or premium modules successfully, because customers are now willing to pay a small premium for long-term safety and performance. In the end, every solar project is an investment that should run for decades. The quality of the module defines how stable that investment really is. A reliable module protects the project from power loss, degradation, and warranty risk. For investors, this means long-term returns with minimal maintenance. That's why today the most successful factories don't compete on price alone. They compete on trust, durability, and performance. A well-built local module with proven materials can easily justify a slightly higher price because it delivers safety, stability, and peace of mind over many years. Thank you for watching this video about price per watt. Understanding your cost per watt means understanding your competitiveness. Even small improvements in process or materials can make a big difference, both in cost and in long-term reliability. If you're planning to start your own solar module production, we'll be happy to plan your factory with you and help you from the very start until the running project.